Today's lesson is about applications involving right triangles. And generally, applications will have some word problems in them, but it can show you why learning something like trigonometry is so incredibly useful. So our first problem involves two boats leaving the same port. One goes 10 miles due west and drops anchor. The other leaves the port 20 degrees north of west. How far must it go in a straight line to get as far west as the first boat? So it sounds a little bit confusing, but let's draw a picture. And I actually do recommend that anytime you have a word problem with trigonometry, you always should draw a picture. That's just a very good idea. So first thing I'm going to do is I am going to draw the port. It's going to be right here. The next thing is just make sure you know where west is. So if you draw a compass, you would know the north is up there, the south is there, west is there, and the east is there. Now, if you accidentally mixed up west and east, you still could get the problem right. It would just have like a weird drawing that wasn't exactly right, but you wouldn't actually get it wrong. However, hopefully you know these by now. So what we're going to do is I'm going to start by drawing my first boat. I'll do the first boat in green. So what happens is the first boat starts at the port, it goes 10 miles, and then it stops. It drops anchor, which means that it doesn't go any further. So then the second boat, I will draw that one in blue, it leaves the port 20 degrees north of west. So north of west means that if I were going exactly west, 20 degrees north of west would mean that I started west and I went exactly 20 degrees in the northwest direction. So that would be kind of like that. This one I didn't draw completely to scale, so it's not perfect, but you'll get the idea behind it. And they want to know how far must it go in a straight line to get as far west as the first boat. What that means is that it's going to keep going until it is exactly to the north of the first boat, which means that it would stop here. So when they say how far must it go, that's going to be our variable. That's what we don't know. And that's actually going to be my x value. So right now you'll see I have an angle, I have two segments. I'm actually going to connect the dots and it becomes a right triangle. So with my right triangle, I can use trig functions that I know. And for these problems, you are free to use your calculator. So what I'm going to do is I am going to first set up my equation. I have my adjacent side, which is the 10 miles. My hypotenuse is what I'm looking for. So when you're working with adjacent and your hypotenuse, that's a sign that you're going to use the cosine. And it's going to be the cosine of 20 degrees. So remember, cosine is adjacent over hypotenuse. In this case, the adjacent is 10. I'm going to write that over x. So from there, I am going to evaluate this using my calculator. You do not need to memorize things like 20 degrees. And when I use my calculator, I find that cosine of 20 degrees is 0.9397. I'm actually going to round it to 3 decimal places. And when I round it to 3 decimal places, it ends up being 0.940 or just 0.94. So I'll just write it as 0.94. And we have that equals 10 over x. From there, you can solve the equation in the best way that works for you. If you want to write it as 0.94 over 1 and take the cross product, that's fine. I personally prefer to multiply both sides by x, because when I do that, I get 0.94x is equal to 10. Then I just need to divide both sides by 0.94. When I do that, I end up getting that x is going to equal 10.638. And don't forget the units. We are working with miles. We're just going to do one more word problem. In this one, we have that a man flies a kite with a 100-foot string. The angle of elevation of the string is 45 degrees. How high off the ground is the kite? So for this, I'm going to start by drawing another picture. First of all, here's my ground. And I'm going to assume the man is like lying on the ground or something, that he's not very tall maybe. So do not like try to overthink his height or anything like that. So my man is here, and he is going to be flying a kite, and they tell us that the angle of elevation of the string is 45 degrees. That means that off of the ground, the angle between the ground and where the kite is 45 degrees. And up here, I have my kite. The other thing I know is that the string of the kite is 100 feet. So what I'm trying to find is I'm trying to find the height of this kite. And the height of that means how high off the ground it is. We are going to have a straight line up between the ground and the kite. So right here, this value is going to be the x. That's what I'm looking for. So you'll notice that I have 45 degrees, I have the opposite side of that, and I also have the hypotenuse. So when you have the opposite and the hypotenuse, you're going to want to use the sine. So I'm going to use sine of 45 degrees. Remember that sine is opposite over hypotenuse. Opposite is x. Hypotenuse is 100. So I write it like that. Now I need to solve this equation, and actually this one, hopefully you remember that the sine of 45 is radical 2 over 2. You actually, since we're working with word problems, I'm going to allow you to use your calculator on this one if you want to. So when you use your calculator on this, you get sine of 45 degrees is 0.707 is equal to x over 100. So all you need to do from here is you can write it as a proportion if you want to, or if you want to make it easier on yourself, you just do the inverse of dividing x by 100, which is multiplying both sides by 100. And when you do that, you end up getting that x is 70.7. And the 70.7, remember, is in feet, because we're working with feet. So don't forget to put that.